Hello. I got a real webcam. Actually, did I check to make sure my mic's on the right mic? How do I do that? I don't know. I don't know how computers work. I don't know how anyone's supposed to use these things. All right, we enabled down mixing. How's my levels? And check your levels. We streaming? I think we are. We're not going to let non-subscribers talk because whenever we let non-subscribers talk, it just gets stupid. Yeah. So this is the PyTorch. This is the tinygrad backend for PyTorch. So many people have asked if we could make tinygrad perfectly compatible with PyTorch. And the answer to this is no. You're never going to make something perfectly compatible. There's always going to be subtle differences. Everything you rely on that is a bug is actually a feature. So probably the best solution for this is to write a PyTorch backend for tinygrad. And I'll show you guys how to use it right now. So let's just make an example.py. All you have to do to use it is import extra torch backend. Okay, let's start by importing torch. Let's say torch.set default device to tiny. Or you don't actually have to set the default device to tiny. You'll see. So let's bring up a PyTorch tutorial. Quick start. But we will set the default device to tiny so we can see what breaks and what works. Working with data. Wow, this is a lot of stuff. All right. Download training data from open datasets. Let's see if this works. We're going to extra torch backend and we'll run example. Okay. Operator torch vision NMs doesn't exist. Why is this? If I import it before, I can't even know, so. Oh, that's not even what this bug is. This is just because I have a different version of Torch. I installed Torch from source. I thought that I broke something with Vision, but not really. Let's just install the default Torch. Oh, and now I have some weird other version of Torch Vision. Okay. Spell vision correctly. It's got to compile something. That's why it's so slow. Okay, great. All right, it's downloading that many megabytes from the internet. Hopefully it doesn't have to do that again. Whoa, torch accelerator, current accelerator, interesting. I don't know why this is so slow to download. Yeah, you happy? Fashion MNIST needs to upgrade their servers. Okay, so we don't have to do that again. Great, let's load up some data loaders. See if that works. Okay, could not run A10 random with arguments from the tiny backend. So this is calling random, and we don't support random. So that's a good place to start. So when you get into what these Torch things are, there's a library in Torch called A10, and we can bring up Torch here. Actually, we can bring up that version of Torch, and we can search for A10 random and figure out what it is we have to implement. Now, I wish there were just standard. Interesting. Is this a real extension? No, this can't be an extension. How come there's not usually a random? I don't know how it's implemented normally. But either way, so we have to implement A10 random. So this is my Torch backend here. And looks like it just does random in place, and that's the generator. What kind of randomness do we have? I don't know. I mean, sometimes you can just get away with this. So if it's that, then we're going to want to assign. We can just ignore the generator and say self.assign tensor.random. Self.shape dtype equals self.dtype. Do we have a method tensor.random? So this is tensor from tinygrad. I think we have a random method, actually. We can read that in the convenient tinygrad docs. In docs.tinygrad.org. You have to spell it right, though. So if we look here at the creation, these are the, so it's probably just rand. So let's do rand, and then this dtype is going to be a torch dtype, so we'll have to do it in this torch to tiny dtypes thing. Great. So that implements, like PyTorch has these A10 things, which it dispatches for. So these are like functions that PyTorch calls on the backend, and then you have to implement them for your backend. So we're implementing them here in the backend for tinygrad. I have a little bit of garbage C++ code, which doesn't really do much, but mostly everything's implemented here. So you can see add submol. By the way, if you're interested in the Torch backend, you're really getting in on the ground floor. This webcam feels hella zoomed in. Like I have the same webcam at home, and I feel like it's less zoomed in, or maybe I'm just closer to the monitor. By the way, I can show you guys now. This is it's an OLED. It's really a beautiful monitor. I love having an OLED monitor. I wish that it like worked nicely like the Dell, so it's one thing to plug in. I just went to the store around the corner for a USB hub. Got a little bit of tea here. Life's pretty good. Okay, so that's random assign random. Let's see if that works. Lambda missing one positional argument generator. So we have this, which can print things out. Okay, there is no generator. Okay, we don't have dtypes long. That is because that's what? Oh, self's already a tinygrad tensor. So do I have a function just called rand-like? That's all I want. So that makes my life even easier. So this is a tinygrad method, and I have a little bit of magic here which unpacks things. Okay, rand only supports float d-types, got d-type long. Great. I mean, that's very reasonable, and I'm not sure what a10 random is supposed to do when you call it with a long. So let's see if we can find documentation in PyTorch that talks about this. So this is the best resource I've found. This does not even talk about it. Great. This rand thing's kind of weird. I mean, what could that mean? Okay, so we can see where it's being called from. We can actually just look at this code. This is the code in Torch. Wow. Okay. Discrete uniform distribution? Wow. That's an interesting method. Okay, tinygrad just doesn't have this method. We have rand, but not random. Is that just a normal torch method? No, this is fork RNG. What? Huh? That's crazy. Okay. So we can mimic that with tensor.randint shape low equals self dot. I have some method here in tinygrad's d-types, which will get me the size, min value and max value. Min d-type. Okay, so it's d-types.min. We're going to import d-types, so great. Low equals d-types.min, self.d-types. This is high is d-type.max, self.d-type, and d-type equals self.d-type. And we can do device equals device.device, but that's not that important, but whatever, we should do it. Great. Okay, cool. So that's working. Now we've added random support. So we added support for like one more method. Now, this is a translator method from the PyTorch to the tinygrad. So to understand what my C++ class does, is it just creates a tensor that's a wrapper of the tinygrad object. And then it has these functions wrap and unwrap. So wrap takes in a tinygrad tensor, returns a torch tensor, and unwrap takes in a torch tensor and returns a tinygrad tensor. Okay, let's create a model. Our example. Neural network dot to device. We don't actually need that, and let's see if print model works. Okay. In empty memory format, sometime d-type is none. that is okay. We just need a default D type. Torch.default default D type. Okay, could not run a 10 uniform. Okay, that's not too bad. You can see these empty memory formats being called. I don't know why they don't have types, but that's fine. So let's go to the Torch backend and create uniform here. That's an assignment, so we're gonna have to do self.assign tensor.uniform. What are the methods to uniform? Low and high, maybe? I think none of the generators are real. Yeah, so we're gonna splat self.shape, do low and high. Valid input shape, okay. Oh. Great. Okay, now we have a neural network and we're initializing them with uniforms. So that's convenient. So yeah, you see when I set debug equals 2 here, I just have it printing all the torch methods that it's calling. Well, at least the ones in tiny backend. There's all these ones that aren't in tiny backend. We can move them to tiny backend, and we should. I guess a sign is fine. Sign should be pretty reliable in tinygrad now. We think we fixed a lot of the bugs, maybe even all of the bugs. Okay, let's continue on with this Torch tutorial. Optimizing the model parameters. Let's link to the tutorial. You need a loss function and an optimizer. So to talk for a minute about why this is important, what this will let us do is everywhere tinygrad runs, you'll be able to run PyTorch. So there's many places where, and PyTorch is getting better, but even things like the MPS backend on PyTorch, it's relatively unsupported. So you'll be able to use the tinygrad backend for that. And then this also just gives us a way, when tinygrad becomes faster than PyTorch, it's just going to be a question of setting your backend in PyTorch to tinygrad, because tinygrad's doing all this fusion for you. The beauty of this backend is it's actually going to be fast, and in some cases faster than PyTorch, due to the fact that tinygrad is lazy already. All right, so we need a train function. Let's get a train up in here. Okay, we really want a device. Fine, you really want a device. Device equals tiny. Also check the model performance with test. All right, and now let's run it. Of course, this isn't actually going to work. Let's just try test first, because then we can get that working easier. All right, what do we not have? Add MM. What could add MM be? So I also have another flag called torch debug, which intercepts these at a different place. I'm actually going to move that to debug equals 3, I think. Okay, so we have a broken as strided. What's add MM? Is that just matmul with an addition? I wish Torch had some documentation, Add MM. I'm sure it does. Okay, never mind. I mean, it's confusing, to know, because this isn't actually the documentation for A10. This is the documentation for, Torch itself. But I think in many cases it's the same. Okay. So add MM, the matrix input is added to the final result. Okay, well, that's really easy. We're just going to do input mat1, mat2. And all you have to do is express this in tinygrad. Which is just that, so that should work. And like, the thing is, if this works, it's actually going to be fast. This isn't like it's going to be slow, because these things aren't actually running. It's just like adding it to the tinygrad graph. Okay, good. We need log softmax out. A10 log softmax. Okay. I don't know why there's an underscore before it, but it's just this has to exist in PyTorch somewhere. All these functions and what their signature is. Like, if I could at least know the signature, that would make my life easier. Maybe this is the signature. What's a structured delegate? Dim half to float. Is that a real argument? So this is just self.softmax dim. Okay, well, looks like it worked. NLL loss forward. So we're just translating these methods into tinygrad methods. And there's probably not going to be a simpler way than just making a big function that looks like this. So I think that we have to do about 250 of these, but that's not actually that many, especially with how simple they are. So NLL loss forward. Where's like the math for this? No, like, come on, this shouldn't actually be a thing. This should totally be, so Torch has this thing, oh, I forget what it's called. Let's go find it. Torch has this thing that's supposed to, here, decomposition. There, okay, here we go. Here, register decomposition. So how do I use the decomposition? Oh, that might be with the decomposition already. Oh, that sure looks like a decomposition. Right, I don't understand why it can't call this. Or are these decompositions not for eager mode? Oh, and they have gathers and stuff? Wow, that looks complex. Yeah, so they're called decompositions in Torch, and they're really nice. I'd much rather use this. So how do I register the decomposition as the function? Maybe I can just do that. Let's just try it. Okay, from torch.decomp.decompositions import NLL loss forward, because I definitely don't want to be writing this. Okay. Then we have a method called A10 NLL loss forward, and we'll call that NLL loss forward. Does that work? Okay. Now we just need where. That's easy. Don't think you can. Let's hope that just works. Oh, does add mm has to have a decomposition too? Why am I writing that shit? Yeah, there we go. Yeah. So instead of writing add we should just be able to do this. The torch decomposition is going to be way better than mine. Okay, we're back on where, but I don't understand. Oh, where.self? Well, where.self means. Try it. Okay, looks good. All right. Now we're on to gather. Expected D-type int64 for index. Did I mess up my D-type somewhere? Long. Make int64t. That's not messed up. I wish you would tell me what it is. Oh, the as strided. Okay. As strided is this nightmare, and we're just going to have to tackle it head on. So I didn't even match the D type here. Like, these are the stride. That just looks like a reshape. See, like, that's so annoying. It's basically like the function with those strides applied to it, but that gets tricky. Maybe we can just do it. I'm gonna have to do the shit to reverse the movement ops. So this basically has to reverse movement ops. Okay. Where's my like get normal strides thing? From tinygrad.shape. So when you create a view, what if you don't? Not views to real strides. Where is it? Strides for shape. That's it. All right, from tinygrad shape view import strides for shape. If strides for shape size equals stride, it's gonna be all in tuples. Let's do that in tuples. If stride for shape size is stride, then this is a reshape. Return tensor dot reshape size. This tensor is a tinygrad tensor. Oh, and we want storage offset to equal none. Okay, so now that as strided isn't broken. Okay, strides for shape takes two positional arguments. Oh. Okay, unhashable type list. Make that a tuple. All right. For some reason, this didn't match. Oh. You have to canonicalize the stupid strides, because if it's 0, yeah, someone's going to have to sit down and really just write this function. Okay, now we need gather. I don't think I have gather in tinygrad. No, I do. It's just going to work. Okay. Some int list. And for those reasons, some reason are those not showing up in the Yeah. Someone's really got to dive into this as strided stuff. Okay. A10 sum intless. Is this just, if I just do sum, is that enough? You also never exactly know with these dispatchers, is that right? Okay, good. Look, we got some, oh, look, that worked. Okay, argmax. Like we also, this is actually really cool because we know if we're matching Torch's API or not. Great. All right. It's running. Ugh, all these stupid ass strideds. I mean, yeah. I don't know if 0 means something special too. But the other nice thing is once this starts to work, you'll be able to run torch stuff with debug equals 2. So you can see all this fusion happening. This is all the fusion from the gather. I don't see the comms and stuff. Are there comms? All these decompositions too. I like decomposition so much. I almost want to put this in, like, put this same thing in tinygrad. Look at this. Look at this in place op. Like, we can decompose all the non-in place ops into in place ops too. Whoa. Prims.uniform helper? Oh, I really like all this stuff. Okay. Where are we? Why are there no convolutions? Are there any convolutions in the model? No, they're just linear layers. Okay, well that explains why there's no convolutions. Why are there no mammals here? That I don't know. Let's see what happens if we enable the trainer. Okay, NLL laws backwards. Well, I have an idea for that one. Oh, love it. Let's see what that decomposes to. Scatter. Do we have scatter? Oh, definitely don't have scatter. Whoa, we have scatter. Let's see if it matches torches. And like, eventually we can just do this automatically. Like GT and LT should be methods. We can ignore the tensor and the scalar. We can automatically do the assigns for this. Like, this is actually just a phenomenal test to see if the tinygrad front end matches Torch's front end, which it mostly should. And then we can run all of Torch's test suite. Oh, that's so exciting. Okay, scatter value out doesn't work. Is that really what's being called? Well, that's not even showing up in the dispatch log because it's being dispatched inside the stuff. That's annoying. use the out version of anything. So like scatter value. Okay, that just seemed to work. Log softmax backwards. Well, that's definitely going to be log softmax backwards data. Is that in decomps? Great, that's in decomps. Well, there has to just be some one-liner to just register all of these. I'm just doing that something wrong here. We have all the Torch guys in our Discord. They can just. I hope that we get enough enthusiasm about this that they're like, George, you're doing this all stupidly. Some int list. Didn't we already deal with this? I have some. That's not enough? Some int list out. We can take a look at, no, I mean, we see the line here. So it's just torch.sum doesn't work. I want to see all the dispatches, but it's not actually showing me all the dispatches, unfortunately. Do we really need this underscore out? Tensor.sum got an unexpected keyword out. Self access. Let's check decompositions and see maybe there's a decomposition for this. Do I look crazy? Is my face too close to the camera? Why does that have such a narrow field of view? I feel like it shouldn't. Like some setting. It's a little wider. No, my whole thing is wider. I don't know if you guys need that width. It's definitely, I look less crazy, look less zoomed into the camera. Got 332 people. Why is no one talking? Good. Distracting dumb shit. Let me see. That maybe? I don't know. Whatever. Enough. Let's check decompositions and see if we can find something for this sum int list. Yeah. Wait, that looks like that is the decomposition. Sum int list out. Whatever. All right, if there is an out dot replace tensor dot sum self access. Multiple values for out, so I'm probably missing something. D-type? I don't know why I need a D-type there. Replace shape mismatch. Okay. I don't understand the outs at all. not broadcast to new shape. Huh? Okay. This stride stuff's just got to be wrong. I don't understand what that's trying to do. Like, what does it mean for that stride to be 0? Is that an expanded stride? Why is the input size that? Is this a permute? Let's just put if get out of torch debug. Let's see a couple more dispatches there. All right. Sum in list out. There's 3 arguments. It should be a sum across 1. Oh, we want to do the same thing for KW args. Instead of printing the keys there, let's print K v dot shape if v is instance v torch tensor else v for kv and kw args dot news. Okay, so that like makes a lot of sense. That's just going to be summed there. I don't even know why that has to allow a shape mismatch. It should not. Oh. Oh, is that keep dims? It just might be keep dims. I was calling it true, but if it's keep dims, it's a lot simpler. So that actually then matches torch. Okay. Threshold backwards dot grad input. Is that in decomposition? It's got to be in decompositions. Here we go. Threshold backwards. What's out wrapper? Interesting. Okay, how do I just run the decompositions? Where are decompositions used? And are they only used in... let's see what docs we can find on torch decompositions. I hope they're not only used in... An exported graph could be equivalent, okay. When writing a Torch backend, how do I enable decompositions? No! No, come on. I'm not logged into ChatGPT. We have to use this one. Ooh, what's that? Ooh, R1 1776. Wow, it's very deep seek. I don't want, but I'm not using Torch and Doctor. No, 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 no. Oh. Is this a function? Get decompositions. Requires A10 ops. Okay. Oh, list of ops to decompose. What if I write a, okay, I can write a fallback handler maybe. The Torch guys were talking about this in Discord. Is it fall through kernel? No, it's not actually fall through kernel, but there's a way to register a fallback. Yes, that's on library. I'm not actually using library anymore. No. Fallback can be registered on the library fragment global namespace. That's A10. Oh, okay, that makes sense. They got a typo. Assert dispatch key is not 0. Wait, what? Basically, okay, so we gotta get fallback working. Oh, no, that's not what goes here. This is private use 1, actually. That should work. Okay, could not parse dispatch key private use 1. device types to register an impl to. Impl register, impl abstract. Show you guys the Discord. Shouldn't be a secrets. So they were talking about it here. It's a public Discord. It's a tinygrad Discord. Okay. They were saying, what were they talking about? Fallback. Great. General backend API. Register a fallback kernel. Similar to your library.impl, but it's library.fallback, but it's not library.fallback. There's faulted kernel, but that's not right. And that's not right either. Oh, that's kind is impl. The PyTorch dispatch key is private use 1. What? Cannot parse dispatch key private use 1. Weird. Let's try to find it in PyTorch. Oh, here we go. Okay, so they get rid of that, and they say dispatch key equals private use 1, but maybe it should just be private use 1 written like that. Yeah, okay. So this was actually just fixable before, but whatever. Let's do that. Not implemented error. What? Why is that different? Why is this private use 1 and this private use 1? Arguments from the tiny backend. Like I want this to hit the fallback, but it's not hitting the fallback. Why not? Dispatch key. Torch. Oh. Yeah, I don't know why that's not hitting the fallback. Let's put that down there. Doesn't matter. Okay, maybe it needs to go at the top. And then, like, instead of tiny backend here, no, I don't think so. No, it just doesn't work. All right, so we'll just hand code them. Does this work? Oh, forgot a colon. No. How about that? Does that work? Useless. Oh, it shouldn't be a string. Maybe it should actually be that. How do I get to A10 actually? Well, that's going to be a whole nother rabbit hole. How do I actually get that? You guys remember that stream when I did ooh. Ooh, that looks nice. Let's see where this is used. Yeah, so I can actually import A10. I've seen this before. Let's find it in Python. torch.ops.a10. Maybe? No. Oh. It should return a dictionary anyway. What? Post autograd, pre autograd, meta? Add op to registry? What is this? Core. Oh. Can I just run that? Core A10 decompositions is empty. How about this core A10 decompositions post autograd? Oh yes, definitely post autograd. All right, that looks like something. Let's register all these. Like, I'm not sure you're supposed to do it like this because this might only be for okay. We want to not do that. We should have stuff like NLL loss forward. That's right there. Default and output. Oh, that's nice. Okay. K dot replace A10 dot with A10 colon. Torch library impl for private use 1. Call that on V. Let's see if that works. Normalizations. String. Default is not a legal overload name. Whoa. Okay. About that. This is not allowed. Well, okay, it's reasonable. Don't upset anybody here. Maybe this one's stupid, and there's a nice decomposition for it. Oh, don't even need 0 either. So what is it using then? This is not allowed. This is already a kernel overriding sums behavior. Okay, 6, so we don't need that. What does it do instead of sum? Okay. Cannot access storage. Oh. Oh, that's not good. It's a NOP decomposition. Oh, now we have to find out which decompositions don't work. Are we having fun, chat? Cannot access storage. A10 alias. What does that do? Running the graph without autograd. Oh, they're questionable decompositions. Okay. Detach. Lift. Lift. Do you see a lift? I don't see a lift. And lift fresh. And I'll just try detach. Did I get it? I should really just hook it, see which ones are being called. Okay. Could not run ATEM. Great. Why is that one not in the list? Okay, so after all that shit, this turns out to be completely useless. And we're still going to need to do a lot of these by hand. I don't know that one. Reshape. Missing required positional argument shape in Torch backend as strided. Oh. Okay. Maximum recursion depth exceeded. What does 0 decompose into? Does it decompose into fill? Because it should do that. right. Looks like progress. Missing one positional argument called keepDim. Maybe we don't need that one anymore. No, we need that one. What the hell did this do? That was so useless. Could not run some int list out with arguments from the tiny. I don't know, what's the default for keepDim? Equals false. And I have int list. What? Missing one required positional argument to keepDim. Great. Grad can only implicitly be created for scalar outputs. Why is it not a scalar output? Oh, we have so much work to do. It's not even running anything yet. Can only be explicitly created for scalar outputs. Is the size wrong? Yeah, I wish this would tell me, like, why this isn't right. Doesn't that look like a scalar? Sure looks scalar to me. Some int list out, keepDim false. It doesn't need to allow shape mismatch. Let's get rid of that. Okay, it does. Why doesn't this work? Oh, because access is wrong. In Torch, if you pass in nothing for access, okay. Well, that's interesting behavior. So an empty sequence means well, that's a compiler backend. If length access, else none. Okay, I'll leave scalar out. Well, that one's easy. Should also, no one ever did the simple math traits thing. When someone does simple math traits, we can, okay, got an unexpected argument, alpha. Well, for each add. Which thing is that trying to dispatch? Right, that should be printed with Torch debug, right? There's no way that's the profiler exit record function garbage. Oh, here, A10 add. Add can take alpha. What? What is alpha? It multiplies? It should be decomposed. Tiny backend doesn't support events. Oh, well, we know that. That shouldn't be required. decomposition for add mm, but it's not used. Okay. Tiny backend doesn't support events. That is correct. It does not. So, but I don't understand because I do this. This is using Torch's autograd. Yeah, stop printing all that crap. Wait, what? So I broke it. These decompositions broke it, probably. Okay, well, don't do that anymore. Fine, we'll do the decompositions by hand. It's not like it helped me anyway. Maybe we should try a whitelist. That's a good strategy. We know this is fine. This is fine. A10 0 is fine. Let's just look at the decomposition for 0 and make sure it's not stupid. I don't even know where it is. Whatever. Can't be too stupid. Tiny backend doesn't support events. Is it because of the 0 thing? 0's an event? Whatever. Put 0 back. All right. Threshold backwards dot grad input. Let's whitelist that. Doesn't support events. But that works okay. Oh, I have an idea that this is just some like async error that it's throwing. Yeah. Really? I mean, it's just a bug that masks itself. I already disabled multi-threading. Even with multi-threading disabled, though, it's still, yeah. You see the problem? I'm not trying to write a Torch compile backend. I want an eager mode backend. Eager. Okay, that doesn't look great. Tiny backend doesn't support events. Calls into the C++ engine to run the backwards pass. I have to change the C code? All right, so this is the dumb crap that I did for this. Tinygrad impl, device guard impl interface. Yeah, that's fine, I think. I don't know how anybody codes in C++, by the way. This language is impossible. Allocating an object of abstract case. Whoa, 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 I definitely don't want to do that. Let's go here. Device guard, no, I want to just super case that shit. Yeah, but no. Is there anything actually there? No, I don't know about any of this. You know, it's interesting how many of Torch's things device guard balls, shit, no. All right, so why is this not allocating an object of abstract class type? Well, shit, guys, didn't want to do that. Better not make an abstract class type, even though it's not a fucking template. How does anyone code in this language? Can I like do this? Can I do that? Come on, C++. Come on. Let me do something that makes sense. Oh, well, of course. Yes, definitely. You can't convert from the tinygrad impl to const that to do that. All right, how about this? Does this work? Can I put the that shit there? Come on, inherit. Yeah, struct tinygrad impl final. Yeah, I want to override some shit. No, don't do that. New device guard impl. Error. Expected expression. All right, how about I put the device type D here, and then I pass the D, I give it the D, gotta give them the D. Is that how you code in C++? I should have ChatGPT. I just paste the shit into ChatGPT and be like, what the fuck doesn't any of this work? Oh, it's marked final. Oh, I can't override it because it's final. Oh. Base device, no guard shit type final. I just wanted to have events so it can like print the thing. Tiny backend that doesn't support events. I don't even want it to have events. I just want like, all right, you guys ready for you know how you really code in C++? Look, I'm a C++ genius, boys. We're gonna copy and paste that shit, paste it right there. We're gonna rename this to tiny device guard impl. Oh yeah, I'm a C++ genius. Yeah, that's right. And people wonder why all code looks like dog shit, and it's because of this. Because who can code in this language? Why is everything syntactically incorrect? Yeah, I did. I meant that. Why can't you just like... Yeah, namespace, of course, because how is your project going to be 10 thousands of lines? And it's 10 thousands of lines because, well, there's a final class and you can't override it. All right, let's just copy and paste it from no op impl device impl. All right, and let's just like comment out that. Yeah, query event, true. Yeah, good. That's what you get when you query an event. Event is just true. Good. All right. Event device type tiny does not match blocking stream device type CPU. What is this? Triton. No. This is a PyTorch backend for Triton, not the Triton compiler, but the NVIDIA Triton runtime. Can't you keep this all straight? Okay. Event device type tiny does not match blocking stream type CPU. I don't know, it's like... this is wrong. Let's try conv2d. Not implemented. That's fine. What does that shit mean? I don't know. This was stupid. We're gonna have to set something in it sometime, so whatever. No, I don't have the same problems as you. I just don't code in C++, okay? That's how, you know, that's how you don't have these problems. Oh, data, great. That's where it's stuck at? Great. No, see, like, this is the problem. We are so different because here's the difference between us, you know? You do that copy and paste and you think that that's something you're going to commit to the final repo. I'm working in a branch. I'd never commit that to the final repo. I don't do shit like that. And that's why we're different. How is tinygrad so few lines? Because it doesn't have any of this boilerplate. There is no boilerplate. Every single person out there who tolerates boilerplate is the problem. I'll just copy and paste it. I'll just do my job. Oh, we just have to ship this feature. And what you've done, it's kind of like, you know how America borrowed trillions of dollars? See, you triggered me, bro. You know, America borrowed trillions of dollars and like doesn't have money because they borrowed trillions of dollars. That's what you guys have done every time you copy and pasted something. And then all the code and all the world's bad because of this. And like, yeah, sure, part of the problem is C++. It really is. It really is. I don't understand the, like, does anyone actually know this language? The language has, this isn't even like, this is readable, but you read some C++ code and you're like, there is no way that anybody understands what this does. Or even here. Does anyone actually know this language? No, like I'm dead serious. Like, why are there 2 ampersands? What the hell does that mean? Like, why is there even 1 ampersand? Like, I know what 1 ampersand means, but what's the difference between an ampersand and a pointer, right? And this is the exact problem. Like, C++ expresses these ideas in 100 million different ways. And you know, nobody can keep this all. It's a bad language. So one of the like tenets of Python is that there should be one way to do things, and this is absolutely right? Because if you have multiple ways to do things, well, people are going to do them in multiple ways, and this is the exact problem with C++. Syntax agility. This is like a Raichu attack. Oh yeah, yeah. Raichu uses syntax agility. It's ineffective. You attack the ground type Pokemon. Yeah, you see what I mean. That's right. We're not the same. And don't see every engineer, every mid-ass engineer out there who tolerates this kind of shit is a problem. I don't know. I mean, I don't know what you do about C++. I happen to really not like C++. Like it's C. C is a great language. You can read C code and you understand everything that's going on. Because it doesn't have like, oh, well, that's a vampire mutability tap. Of course, but what is it actually? There's not any assembly language that has that kind of shit. All right, so C++ is the worst of both worlds. It created all these things which aren't real things. They only exist in C++. And it gives you almost no benefits. Fine, you want to talk about all like the Rust people and their box and stuff? At least in Rust, you get memory safety. C++ added all this bullshit for nothing. Syntax agility, yeah. No, we're not. No, this isn't happening. No, it's too ugly. See, I told you I wasn't going to commit it. I told you we're not the same. So, who's excited to come work on the Torch backend? I mean, this example is kind of crazy because it's like really complex. Let's find a simpler example. Because that's not going to work. There's actually a $200 bounty if someone can do this. So let's find a simpler example. Torch example. Image classification. Is this going to train something? No, it's trained. I don't want to train. I don't want to train. Oh, stuff's crazy. How do I not train? Well, now that I know Torch Vision works, let's just try to run ResNet. This is stupid. Where's my... I have this in something, don't I? Did I delete it? I like the perplexity editor one. Torch code to run ResNet 18. Yeah, Torch Vision models. Yeah. Oh, you might need to. Yeah. No, I don't want to train. No, stop trying to train. Yeah, that's what I'm talking about. Yeah. There we go. Okay, how do I just add the back end? Yeah, this shit. I should just copy. Why don't I delete that all? Set default device to tiny. Torch.random. So 1, 3. I have some ResNet 18 stuff here. Torch uniform? Torch have a uniform method? Run the model on the image? And then convert it to NumPy? Do that. Gonna work. All right. We don't support normal. Out of a decomposition? I don't want normalize, I want normal. No. Where's A10 normal? Why doesn't this have a decomposition? Is normal the same thing as uniform? Oh, whatever. Okay. Great. These all have standards of integrate. Python has terrible lambda syntax. Okay, native batch norm. Come on, come on, come on. Have a decomposition. Oh, decomposition, please. Yeah, native batch norm helper, native batch norm decomposition, native batch norm. All right, let's just see if we can whitelist it. That'd be the absolute best. Is that in the bullshit? No, not that easy. Okay. Native batch norm backwards, but not normal native batch norm. I see, of course, because that would be too easy. Native batch, well, hang on. Where's that function? If I just call get decomposition on it, it should work, right? We just do this? What do I have to call it on? Oh, piece of shit. What? If I call this on like something that I know works, let's try like leaky ReLU. Does that work? Oh, am I just not? Do I have to pass in a fucking union? Yeah, that's okay. Great. Op overload default. Oh, there's probably some way to go from like this op overload class. Get rid of that shit. All right. Cannot impact non-iterable. All right, well, that's great. Stop being iterable. Okay. Yeah, but see, that's an op overload. Yeah, why am I trying to... All right. Torch ops overload. Let's see. See if we can convert it to the other A10 type with the colons. With the lemons. Namespace. Handle. Repr. Redispatch. Get dispatch. Op? That work? Come on, have some colons. Oh, built-in method of Py capsule object, of course. Where does this have the colons? I saw some colons in there. Self.schema. Schema name. Op name? Or just self-schema name? Let's do the schema name. George, it's pronounced schema. Oh, there we go. Beautiful. Oh, but that doesn't have... No. No. It's got to have the stupid thing afterward. Oh, look at that. All right. Well, we don't want it to be a name. What's the type of the schema? It's a function schema. Okay. That's pretty cool. It shows you the whole, like, that shit. We could just do a split at the thing, but we're not going to do that. Oh, of course. It's written in C++. Signature? Signature. Let's try that one. It's a function. Oh, well, it doesn't have a signature. It's reasonable. Great. Okay, we can check if it is backwards compatible. We can check the name. We can check the overload name. Maybe we want the overload name. Let's try that. Oh no, that's just that. Okay. Oh, maybe operator name. Let's try that. Could that be right? That doesn't exist. It's right there. No, it doesn't exist. Don't worry about it. Arguments, returns, clone with name, argument list with name. Dump. Okay. So yes, we are. Oh, I know exactly what we're going to do. We're going to call string on k.schema, and then we're going to split it by the parenthesis. And go like that. Torch library info, all that. Private use 1. Oh, and now I need the function. How am I going to get that? op overload. It's probably like already code to do this if I actually knew what I was doing. Oh, so I can just call it. So I can just go like that. Okay, native batch norm, here we come. All right, well, don't recurse a lot. It's not good. It probably wasn't K. PyImpl? Let's see if that's what we want. Oh, well. Takes two position arguments, but one was given. How come that has dot items, but this doesn't? They're just calling get decomposition. No, this isn't right. So how come I can call dot items on that? Let's try dot items. And then we can do this. This should work. Okay, great, cool, that worked. Let's get rid of this and get rid of this. And then like if we want those things, we can just add them to the decomposition list. All right, so let's like check this out. So we just do like a10.native batch norm. How about a10.varmin.correction? Why is there a dot there? Empty strided, missing one required argument, layout. That doesn't matter. Var correction. Okay, that's var mean. Let's see if we can do a decomposition of var. Maximum recursion depth. Yeah, so you like, it's probably just like writing one in terms of the other. You know what I'm saying? You know what I'm saying? So this one can just become a10.add.mm. That's gonna work. Yeah, okay, so you probably can't do that. This is not allowed. Oh, well, good. Shouldn't be allowed. Okay. Var, you can't have var and var mean. You have to do one. I mean, that like makes sense, right? Like you can decompose one into the other. So let's just try a10.var. Do I need to call it var.correction? Let's call it var.correction. So it matches tensor.var. Okay, well, good. That's a different problem. Interesting. So what happened to sum? Why did I get rid of it? Did I try to find a decomposition that could do it? That doesn't make sense. Do I have var mean already? I don't have that one. Okay, we'll decompose it. But what's trying to do that? Okay, something in custom ops. Check aliasing constraints. Interesting. Oh, we should have. Yeah, okay. Why don't we have var mean? We should just write that. Whatever, don't decompose that. I don't trust that decomposition. Never mind, I take back my love of decompositions. Okay, lambda self axis keep dim correction 1. And what we want to return here is, no, that doesn't work. It's going to require a fancier thing if we want to do it like that. But okay, why doesn't that just work? Let's bring this up and look in reduction. Prim. So there's some primitive here where this is breaking. And that's calling ops. Prims.var. Oh, prims.var, not a10.var. So what if I just try that? Does that work? Prims, you can't do that. Just because I'm calling it with a10? Yeah, it's because I'm calling it with a10. Didn't work. get rid of that one for now. And we will make this work. So we have to return dims, keep dim equals false, and correction equals 1. We want to return a tuple of self.var dims, keep dim, correction, and self.mean dim. See, like, again, in tinygrad, all this stuff's just, like, you don't have to worry about that because that's actually fast. And then here, if is instance out, if is instance out tensor, return wrap out. If is instance out tuple, return tuple wrap x for x in out. Else raise runtime error, unknown type out. All right, no R squirt. Rid of all this crap. Rid of all this crap. This crap. Register some decompositions. Yeah. Great. I don't need that. Stupid. I don't know why that doesn't work. Let's move that down here. Fine. And it's looking like acceptable code. We have a problem with R square root. Is there a decomposition for this? There should be. Better just decompose into R and square root. Maximum recursion depth exceeded. I think it's calling into prims. Huffing and puffing a lot, I know. Okay. Well, can't broadcast that. That's not supported under PyTorch's broadcasting rules, is it? PyTorch doesn't let you do that. I have to have just gotten a shape wrong, right? Yeah. All right, so where's my wrong shape? All right, where is that tensor coming from? Where's that 64 coming from? I broke keep dim, right? It's probably got to be. Oh yeah, I got to pass keepdim into mean as well. Mean has keepdim. We should just support. Support var mean in tinygrad. Oh, this is a great exercise. Because this is like, yeah, see, you pass in keepdim there, and I didn't pass in keepdim there. Oh yeah, we need to get these functions into tinygrad. Oh, I'm so happy we're doing this. Great, that's fixed. Okay. In place ReLU. Max pool 2D with indices. Can I decompose that? You cannot. Or does it just not register the decom? Because there isn't a decomposition for that. No, there isn't a decomposition for that. Okay. If there isn't a decomposition, then what can I say? I'm gonna have to write max pool 2D with indices. Put it up there with convolution. Where's convolution? Some torch functional input max pool func 2D options. Oh, great. Is it like this? No, it's not like that. Max pool 2D with indices. Oh, because it returns the indices. Does tinygrad support this? I'm not sure it does. No, it doesn't. Great. Yeah. So, this is seen in my favorite Star Trek Voyager episodes, Future's End, where Henry Starling is trying to jam the teleporter using his thing, and he said, it's supposed to jam your ship's teleporter. It doesn't work. And he's like, it works perfectly. You just don't know how to use it. And that's how I feel about this decompositions. Maybe it works perfectly and I don't know how to use it, or maybe it just doesn't. Okay. All right. Good progress. Torch backend progress. We backend progress our functions. Let's see if like something like this works. I definitely have like test max pool in there, right? So this is tinygrad's test ops. Max pool 2D simple. Tiny backend equals 1. Yeah, I don't know about this. Object of type none type is not an instance of sequence. Wait, what? I don't even know. What an interesting error. Oh, I see. No, this is fine. It's just because I broke that. It's because I added half-ass max pool somewhere, right? Yeah, here. So print options, but it's not options. Yeah, so we don't have this. An implementation of it somewhere? Okay. Self kernel size, stride padding. Oh wait, this is cool that it like right here it shows the. We should be able to like auto parse this stuff. Or Torch probably already does this for me. Seal mode equals false. We want self dot. Self is a tensor. Max pool 2D kernel size. Stride. Dial. Are our arguments in a different order from PyTorches? Padding. Seal mode. We can try that, but I don't think that's going to work. Tensor has no object. Max pool 2D. What? Oh, because I have to unwrap. I have to wrap this. Stride dilation mismatch. Oh. Well, that shouldn't be that. Just set stride to none. There's another. Expected a proper tensor, but got nothing for indices. Okay. We need indices too. How do we get that? What is the return of that? Indices in tinygrad. Torch doesn't even use this. So you're telling me, like, it's probably actually writing this crap out to RAM all the time. We'll return indices. The max indices along with the output. What's the return of this? All right. Each one value. Input what? I don't know, what if I just do this? Wrap tensor.zeros like rat. Yeah. But they're indices, so I don't know what type should they be. Yeah. Oh, max pool with indices backwards. Oh, come on. Decomposition? No. Wait, what? Why is it even what? I don't do anything backwards. Oh, that one does backwards. Okay, never mind. Yeah. Now it's gonna work. Yeah, forward only. That's right. That's right. We don't have mean. Someday I'll be living in a big old city, and all you're ever gonna be is mean. We do have mean, we just don't have mean.out. Now I can't really want mean.out. I still don't exactly understand like what this .out stuff means. Mean.dim. Oh. Yeah. But it just ran. Yeah, buddy. All right. We're gonna make this work, and then with this we're gonna wrap the stream up. Okay. So why did it only run 2 things? That's not good. It's not good at all. What? Oh, probably because, yeah, okay, this strided thing doesn't work. I gotta fix strided. I don't understand. Like, this isn't, why is it 0? Okay, we have to get to the bottom of that strided. Why is that 0? Like, shouldn't that stride be 1? If you don't want that to just be the first argument? Yeah, torch squeeze shouldn't do that. Okay, we're not understanding what stride means in as strided. 0 must have some special value. Stride of the output tensor. Oh, let's just try this. Yeah, look at them. Look at those kernels. Look at them kernels, boys. Look at that. We got like convolutions and shit. All right. I mean, it's a lot of kernels compared to the tinygrad implementation. I don't know why it's so many kernels. So like, this is the tinygrad ResNet 18. Yeah. 61 versus 140. I don't really see why that's doing that. Looks like it's running everything twice for some reason. Once with variance. Like, nothing should be realizing. It's scheduling 150 kernels. Okay, cool. This would be cool if it actually exposes some scheduler bugs. Great. Let's finish example here and let's load a real image. Where's chicken? We love chicken. Chicken's one of my favorite images in tinygrad. Pre-process. Pre-process chicken image equals torch.tensor. Does that work? Test on package. Test is not a package? What? Is it a package now? I don't understand. Python path equals dot. Did I spell it wrong? I don't know. There's gonna be some like torch shit to test this. Let's keep it in. Let's keep it in torch. Torch vision. How do I get a? All right, DeepSeek, you can do it. That's good. So this is where we're going to leave it, and we have 2 bounties up. No, not deepseek.com. We need labs.perplexity.ai. All right, cool. Yeah. Can you make it load an image of a chicken instead of random and confirm model say chicken? Good LLM. You are good LLM. What? You're thinking way too much, DeepSeek. Yeah, that's a good point. 288 might not be right. That's right, it's probably wrong. Let's try 44. See if they look like probabilities. Are they all zeros, or even worse, nans? Oh, I can't. Fucking requires grad. How do I do with no grad? Oh, that's why everything's so crazy. Because we gotta do with torch no grad. It'll work better? Looks better. All right. Oh, it's even less kernels. Never mind, I lied. It's the same kernels. All right, that looks good though. Those look like probabilities out argmax. That numpy. Okay, that random was a 622. Wow, this thing loves talking. All right, what? Good LLM, you are good LLM. Chicken means 7. Top K, wow. Pretty nice, right? Yeah, let's make it look crappy like all the other LLM code on the internet. Where's the chicken? There's a chicken that lives in tinygrad, actually. Is there? I thought there was. There's no chicken? Oh, there's the chicken. Pathlib. Code is so long. I hate when code is long. I need one more parent. Is there a way to do like parent sub 3 or something? Whatever. Okay. Yeah, no, I got you, bro. I'd be upset too. The tensor. Oh, what? Are you kidding? DeepSeek. You forgot one. DeepSeek's fired. Can't believe it forgot one. You see what it forgot, right? Grok would never forget. Grok remembers. These even the right numbers? Okay, good. These numbers exist everywhere. You literally, how are you so stupid that you forgot one? Or did I delete it? And I'm just insulting poor LLM. All right. Oh, well, guys. Obviously this isn't going to work. We don't have the slow conv2d forward. Are you kidding? How does this even break? I don't even get it. Is the D type wrong? Float 32, what? How is it different when I add random? Is shape wrong? Shape's probably wrong. Yeah, shape's wrong. Is that right? Guys, we didn't implement slow conv2d. What a miss. How do you still have that? Can I commit this? Please let me go. Well, that doesn't need the slow conv. How do you even know the difference? Is it the device? Sure looks the same to me. It can't, no. Oh, what? Why is it on CPU? How do you, what? All right, whatever. Didn't respect the default device. All right, we got a 622. That's not good. So which of these many stupid kernels is wrong? Or is it just like not loading weights right? Or is it not loading the image right? Or is it not loading the model right? That looks like a chicken, right? Does that look like a chicken? That looks like a chicken. So which thing's wrong? Which of these many beautiful functions is somehow wrong? Test ops, test var. Tiny backend equals 1. Seems right to me. Okay, that's fine. What's 622? What if that's already a chicken? Oh, 622. Yeah, let's look it up. Oh, that's a lens cap. It's a funny category. All right, we either want a cock or a hen. Just so you guys can see what we're dealing with here. Maybe you guys should take a look at the chicken. All right, so there's our chicken. Just so we're all on the same page here. All right. So that's clearly not a lens cap, I would say. In my expert judgment, I would say that's not a lens cap. All right, so like what doesn't work? Sign value is fine. Var is fine. Var mean is fine. It's probably fine. Hope it's not using scatter and gather because those things are mad broken. Batch norm, add mm. Is it dinner? If you want. What do we got? It smells good. Oh, is this the stew?
It's sukiyaki.
We're on stream. You want to say hi to the streamies?
Hi.
Got a better camera now.
Oh wow.
It's sukiyaki.
Yeah, it's sukiyaki.
I don't know that word.
It's like slices of beef, and then they're cooked in a pan. You've had this before.
Suviyaki?
Sukiyaki. It's Japanese.
Do you want to see a picture of a chicken?
Yeah, let's look at the chicken.
Here he is. Yeah.
You know, he was here the other day.
Yeah, I know.
I'm a little traumatized.
Yeah, you can see he's still got a head on him.
Yeah,
But
the waddle, the crest on the waddle.
The program thinks that he's a lens cap.
Oh, he would make a bad lens cap.
Great. Yeah.
That would be strange. Alright, I'll leave you to it.
Is that already?
If you want it to be. I was waiting until.
I'll come down soon after we get the chicken.
Okay, bye.
Okay, so like, you guys see any bugs? I don't know how I'm gonna find bugs in this. So like one of these many beautiful functions has bugs. Copy. If you copy, it's probably likely to have bugs. This just looks like a bug. Look at that. Looks like a bug, right? Yeah, I know. Yeah, doesn't that sound fun? Alright. Yeah, LM to do this. I mean, I'm gonna guess it's like one of these. As stride, it's being wrong. Don't you think? Don't you think it's got to be an as strided? Yeah, okay. Does anyone understand, like, what? Wait, what? Oh. I don't even understand. How come, like, the strides are stupid like that? They should all just be reshapes, right? Okay, we clearly don't understand as stride. Oh, look at this. That's a permute. That's why it doesn't work. I don't understand how I'm supposed to know that though. Wait, also what? Oh, that's calling torches reshape. So what if I do that? It's going to create an infinite loop. Yeah. So for this, hi, one quick question. So So here we can do unwrap. $463. Are any of the others secretly permutes? Okay, let's see what a 463 is. A bucket. All right, so like, what? How's that supposed to work? As tried, it clearly just doesn't do what we think it does. But I don't see any of these other things being really wrong. They kind of can't be. They're all reshapes. Like, they're all stupid reshapes. Looks like just ones and shit. None of them have offsets. Yeah. Permute. Order. It's gotta be right. All right. So where could the other bug be? The other 6 bugs, I mean, sorry. Why are they not just using views? Because I'm just passing that through to like normal reshape here. There's something I'm missing? Are the weights not getting loaded correctly? That's a real possibility. They look correct. Actually, what's really cool is Torch is calling all this random crap, but it's never actually realized. Torch is so wasteful. Oh, that's a good point. Yeah, I could just call to CPU and then call to tiny. My copy works. Now that's a smart idea. Just like use Torch's CPU. Wow, Torch can do all this really cool stuff. I don't know, like what if I write this? No, that's not gonna work. Let's just continue to hopelessly stare at it and then hope I see something. Why isn't that doing a reshape? Why does it have stride 0? Interesting. Look at this. It's it's followed by the view there because that's actually because I'm not doing the reshape in I'm doing the reshape in like Torch. Huh. I mean, I guess like that could be the problem. So what if so what if I just literally write that one? Tensor CPU dot as strided size. Oh, this isn't gonna work. Actually, that whole approach might not really work because okay, well, now we got an 899. The problem is it's not tracking the internal shape correctly. Like, it's making assumptions you really can't use as strided. What's calling as strided? Like, Torch is making these assumptions about how your memory works, which aren't really correct. All right. From Torch squeeze in native batch norm helper. Is there not an 810 squeeze I can use? That one's kind of crazy. I mean, squeeze is really just a reshape, right? When is squeeze not a reshape? All right, let's look at torch.squeeze. See, 810 squeeze. I wish it wouldn't use us strided. I mean, I could. No, it's good that it's using. Okay, what's going on here? That can't possibly mean that. Oh. Okay. This thing has strides? I thought opaque tensor implication didn't have strides. is non-overlapping and dense. What does that mean? Custom strides. Yeah, so like this shouldn't work. What is that used for? Let's take a look at the tensor. Why doesn't abs work? Oh, because it used to be abs died out. Maybe that'll just work. Okay. What? Is it looking forever? Oh, it's looking forever because that actually calls us strided. Okay, whatever. CPU.numpy. You have to detach before you can go to numpy. Right, like that looks like a real thing. But how could the stride be 0? Okay, maybe I just don't understand something about custom strides. If length of size is 1 and stride sub 0 equals 0, this is squeeze. So we just do tensor.reshape size. Okay, that can't ever be wrong, right? And storage offset is none, and stride is 0, and prod, and tensor dot size equals, what size is not, size in torch means something different. This is also not a tensor, it's a torch tensor. Tensor.numl. Okay. This is a different one. This one has 2 1s in it. So what's calling it? This is unsqueeze. Unsqueeze has 1s. This is baffling. Why does squeeze use as strided? Stride 0 means there's 0 bytes between each element, exactly, but that just means it's repeated. Right? Like it's not, like it should be stride 1. This stride actually makes sense. Okay. Let's just go nuclear on this shit. Let's say if x for x in tensor.size, if x not equal to 1, size shape equals tuple size, x for x in size if x not equal to 1. Okay, now we have this one from the end of one element to the beginning of the next element. Okay, now we're getting 463s. Which is not the lens cap. It's a bucket. So does that do the same thing if I do that? No, because that's actually wrong. The tinygrad one is more correct, I believe. Okay. I mean, this could also not be a Bermuda. This could also be a reshape. But I don't think that's right. This doesn't change anything, does it? No. Well, no, I don't think so, actually. Okay, we can. Yeah, okay, we can try the wrapper. Yeah, I guess we kind of want that fallback thing to work. It's not, again, it's really not as easy as you think, because you have to go in and you have to like convert each tensor, right? It's not just like all the tensors. Actually, before we go crazy, let's just try something stupider. Could my example just be wrong? Before we go crazy, let's just do that. Oh. Yeah, so about that. Yeah, all right, cool. Well, it sounds like a good project for you because there's actually nothing wrong with our shit. It's just not something else is wrong because it doesn't work on CPU either. Yeah, I mean, no, I agree the wrapper's a good idea. And you should get like the fallback to work, and it should actually like this stuff. There should be a great tutorial somewhere for like implementing a backend in Torch. Okay, what's wrong with our chicken? This code doesn't work. Oh, is it flattening my chicken? No. I have those transforms somewhere. This is so annoying. Like this kind of crap. All right, did you figure out what's wrong? Use weights instead of pre-trained. I don't think so, but I'm okay with that. It's kind of fine, but it's still broken. We have a car as well, I believe. Let's see if the car works. Car is also 463, which is interesting and lends towards just this whole thing doesn't work. Let's just make sure we're not importing the tinygrad stuff. Okay, same exact bug. Oh. There you go. Yeah, dumb crap. It's using the wrong bash norm. Stupid. Stupid. Okay. Device equals tiny. Let's see if it works now. All right. So now we just don't have square root. That's not a big deal. Put it right next to our square root. So like most of that crap we didn't even need. Reciprocal. Oh, is there a reduction for that? Come on, there's got to be a reduction for that. Recursive crap. There you go, same answer. And we forgot eval on our model. You know how many like bajillions of man years have been wasted? Wow. Wait, look at how few kernels it is. Is that more efficient than the tinygrad one? Sure looks like it. Beautiful. That's beautiful. That's fast, too. That's really fast. Because it's not actually doing anything. Awesome. Cock. Yeah. All right. Check it out. This is easy. Okay. Let's understand this strided shit. Because that's not actually mergeable. But otherwise I think everything's mergeable. It's probably mergeable, but the strided shit is too much of a hack. Which is faster? This is definitely a later project, but so it's 26 mils. I mean, you'd have to use the tinyjet. You'd have to tinyjet to really compare them, but I'd be surprised if. Well, it's faster than CPU, obviously. Oh no, I don't know. It's probably not faster than MPS. MPS is faster. But now it's in tinygrad, so you can just use beam. Right, like that just works. We're just gonna beam and torch. I'll go P while it beams. And then we have suviyaki to eat. I don't know, we could leave it as tried as an exercise to the reader. Oh yeah. Now it takes 12 milliseconds. What a deal. Yeah, actually, I think we can leave that as an exercise to the reader, as it's not wrong, my as strided. Like, this isn't wrong. I just hand-coded that one case. And somehow you're supposed to know that that's that. Why is that that? How am I supposed to know that? Like, how is that that? I don't know. Don't. Yes, mean, that's fine. Backend. So yeah, we'll leave as strided as an exercise to the reader. And we will add this to CI. We'll let non-subscribers talk for a little bit, but if we have stupidity, it's going to be a quick end of this stream. Cool. We don't actually need to print that, do we? Or what's printing that? Whatever. Don't buy AMD. It's unless you're willing to use tinygrad or wait for this stuff, the default stuff, it's just bad and it always will be bad. Like they're misunderstanding what they need to fix to make this stuff actually usable. They say they don't. They say they get it, but like, you know, you can look at their tweets and you can see if that's the stuff you care about, or, you know, maybe making the driver stable. It's still unstable. If you use our stuff, if you use our PyTorch backend, it will use our driver, which is stable. And we have a complete driver for but it only works on the 7900 XTX or the 7600. If you have an RDNA 3 GPU and you want to use the tinygrad stuff, you shouldn't at least have driver crashes. But really, just buy NVIDIA. Why am I up so late early? I live in Hong Kong. And it is a balmy 8:22 p.m. here. Wow, look at that. Look at that. It's beautiful. It's beautiful. Look at all those reduced kernels. By the way, if you guys haven't seen this, should just work. Okay, so now this is from Torch. But this is so good. We should have done this way sooner. The Torch guys on Twitter were suggesting it, and they're so smart to suggest it. Because now you can just use all of tinygrad's nice stuff with Torch as a front end. So these are your kernels. This is what your scheduler graph looks like. Unfortunately, that's gonna brick. Oh, no, it's not. Look at this. So these are all the kernels that are running in that, yeah. Copying in all the weights, doing the prep for the batch norms. And then this is just a random reduce kernel. So you can see all right, we gotta multiply. Well, here we can go here and you can see it before that. So it's multiply, reduce. This looks like some batch norm math all grouped together. Reduce that, throw the whamming in there. We definitely should have been a PyTorch backend earlier. And it's great because it turns out to be almost all of the tensor.py stuff exactly. Which is where I want to get to with Onyx and PyTorch. So I want to maintain tinygrad going right from Onyx and tinygrad going right from PyTorch into tinygrad's tensor front end. So tensor is going to be this superset that supports everything, and I want to get all the Torch tests starting to work. This is unlocked something major for tinygrad. Yeah, bend over for Jensen. That's right. I'm glad you like Amanda. Glad I have chat's approval. All right. Any other questions? Wow. And what we can do, so these are the tensor things, but we can even figure out which PyTorch op is creating each one of these. This all just works. Yo. We'll see how far we can go with this. But I have super high hopes. This is going to instantly make all PyTorch code just work on tinygrad. Just by doing this. And now you can use Torch Vision, you could use everything. PyTorch, and this way we're just not competing with PyTorch. I never really wanted to compete with PyTorch. I am totally fine with PyTorch's front end existing forever. You don't have to write in raw tinygrad. You can totally just use PyTorch's front end and use all of the existing PyTorch code. Use PyTorch's gradient library. Yeah, I mean, you'll see. You'll have to end up using tinygrad's gradient library in order to implement some of these PyTorch backend methods. Oh, this is going to work so nicely. All right. Thank you for watching today's stream. I appreciate most of you. To those of you who I don't appreciate, well, not everyone can be a winner. Not everyone can be a winner. Quantum hardware. What a positive note to end the stream on. Yo, that's just being real. Why didn't we think of being a backend for PyTorch in the beginning? It's not there's almost no extra work. The thing about this PyTorch backend is all it is just calling, tensor is the highest level of abstraction in tinygrad. And I want to keep it this way. I don't want to start like diving in where the PyTorch thing is bypassing things. I want the PyTorch thing to continue to use all the tensor methods. And whenever we have a tensor method like varmean here, like I don't want these one-liners. I want tensor.varmean to work. I want tensor to replicate PyTorch's front end as much as possible. Yeah, no, and it's great. Now we also have tensor.gradient, so it should be really easy to implement this gradient stuff. Oh, this is going to work so well. All right. You can contribute. ResNet works. You can contribute to the Torch front end. The only reason that I'm continuing to do streams, would NN helpers like conv2d remain in tinygrad? Yeah, probably, but that stuff was never great in the first place. I never really liked the NN stuff in tinygrad. It's like, it's not big, so we'll keep it. Like, it's only that big, so it's like kind of nice to have. But I really like the idea of like Torch handling this layer as much as possible. I don't know. Actually, maybe we will rip this out. We haven't gotten optimizers and stuff working yet, so we'll see. How big is NN? I mean, NN like state is good too. NN's only 412 lines. It's not that big of a deal. It's not much of tinygrad. Zerover.org. Oh, is this like how you're supposed to do versioning right or something? Or am I about to get like rickrolled? Whoa. That's cool. Wait, yeah. I should be on here. We got more stars than a whole bunch of these. Like how much stars? OpenPilot's got more stars than OpenPilot has 52.6 thousand stars. So OpenPilot falls right here. And it is still on version 0.97. tinygrad is slightly less popular than OpenPilot. Oh, you guys wouldn't believe what comma shares are selling for these days. It's ridiculous. Ridiculous. Everyone's starting to figure out the whole world's fake, you know? Everyone's starting to figure it out. C++. All right, no, we're well in rant territory. No, yeah, like PyTorch and tinygrad should pretty much be the same thing, and it should be the lightest weight shim possible, but this is an incredible testing opportunity that this has opened up to tinygrad too. We'll be able to run all of Torch, every Torch test suite that exists will work on the tinygrad backend, and it's just basically this. They're just the tensor methods, and whenever they're not the tensor methods, like random, like we should support random. We should just support tensor.random. Yeah. So, very exciting stuff. Thank you for watching today's stream. Never mind, you're all winners. If you're watching my stream, you're a winner. The losers are out there not watching my stream. That's right. Bye. Bye. There's the camera.